So this is a family of Poncelet pentagons interscribed between an outer circle and an elliptic caustic where one of its foci coincides with the center of the outer circle. Okay, so here's the family. In this case, it's n equals 5. And what I'm showing up here is that as I vary or as I traverse the family, the sum of the side lengths squared is being conserved, as is the sum of the double angle cosines of this family. Let's try this example for n equals 4. I get the same phenomenon. Now, interestingly, for n equals 4, the sum of the side lengths squared seems to only depend on, it's basically 8 times the radius. Currently, my radius of the outer circle is 1. So even if I consider all possible families here, for n equals 4, you can see here that the sum of the side lengths does not change, side length squared. And it's conserved across the family and across all MacBeath possibilities here. There's a 1D family modular rotation, but you can see that the sum of the side length squares for n equals 4 is always equals to 8. So I think it's 8 times big R. Now, cosine of double angle, cosine of double angles, or the sum, is also conserved. Now, if I change my a here, for n equals 4, I get a different value there. And when I go to n equals 5, the sum of the square side lengths depends on the particular eccentricity of the caustic, okay, but over the family, it is conserved. Let's try finally here for n equals 6 to see if anything interesting happens. It is dependent on the choice of the caustic, but it is not dependent on the angle. Now, I'm including also the product of cosines of the internal angles because we saw that for n equals 3, apparently this quantity was being conserved, but it is not being conserved for n equals n greater than 3. Okay, so there you have it. Conservation. Let's just do something wild here. Let's go to n equals 9. Okay, so here's a MacBeath for n equals 9, and you get the same conservations, but you can see here that the product is still not being conserved. This starts to get a little bit numerically unstable, but you can see here there's a little oscillation on the product, whereas the sum of the side length squares. Let's go to, say, 8 to see if this is still the case. Yes, the first 2 quantities are conserved, but not the third one. Okay, so that's what I have for now. Thank you very much.